Hello, in this video, we will be using Ansible, EEM scripts, the archive feature, and an IPSLA tracked object to configure and automatically roll back changes to remote Cisco iOS devices. Just a quick side note before we get started, the Ansible playbooks that are used in this video will be available on my GitHub for reference. Let's quickly look at our topology. We have multi-area OSPF running with a single point-to-point link between each router. Our Ansible control node is connected via a remote network to R1. The router we want to configure in this video is router 3, which has the IP address of 10.64.0.5/30, so it's a point-to-point link and it's applied to the Gigabit Ethernet 0/0 interface. Gigabit Ethernet 0/0 is router 3's only reachable interface. Ideally, we do not want to make any changes that will leave R3 in an unreachable state. Okay, let's begin. First of all, let's look at the running configuration for Gigabit Ethernet 0/0 on router 3. We have message digest authentication applied, currently with the key Cisco. We also have OSPF fast hellos with a minimal dead timer, just because we want our neighborships to fail quickly when router 3 is left in an unreachable state. Now over on router 2, once again, we have OSPF message digest authentication with the key Cisco. And of course, to form the OSPF neighborship, we have reciprocating OSPF fast hellos and dead timers. So currently both routers, router 2 and router 3, have message digest key 1, which is Cisco in all caps. We want to convert both routers to use message digest key 2, which will be Cisco 1. I appreciate that it would be better practice to have both keys or the new key on each router and then remove the old key. However, for this example, we want to show how we would reconfigure router 3 by removing the old key and then adding the new key. So removing key 1 and then adding key 2. With this configuration, connectivity to router 3 will be affected. Okay, so just to clarify, R3, our remote router, will have key 1 removed and become unreachable. We will then be unable to add key 2 to bring reachability back, particularly over an SSH session. R2 will have message digest key 1 and 2 applied. Also, it's important to bear in mind that the message digest key numbers are only locally significant to the router. Before we reconfigure router 3, let's just quickly apply the new message digest key, key 2, to router 2. Perfect. As you can see from the running configuration, message digest key 2 has been applied to router 2's Gigabit Ethernet 0/0 interface. Router 3 still only has key 1. Let's log into R3 over SSH now and try to replace key 1 with key 2. As you can see, and as we predicted, reachability has been lost. This is not a good situation to be in, as G00 was R3's only reachable link. Let's rewind now and let's try that again. But this time let's try pasting the configuration rather than typing in each command individually. Predictably, our session went down again. Only the first command gets applied before the neighborship goes down and the router becomes unreachable. So how can we avoid this? Let's log into our Ansible control node and find out. I'm going to be using VS Code in this video, but feel free to use any YAML editing software that you find. Let's quickly overview our host file. We currently just have it set up to configure R3, which is our remote router. On port 22 SSH, R3 user, R3 password. It's also set to the network OS of iOS because we're editing Cisco iOS and it's using the network command line. And just for reference, our remote session will be created over the IP address 10.64.0.5. Like discussed earlier, this is the /30 link, and it's a point-to-point connection between router 2 and router 3. Okay, now let's look at our first Ansible playbook. Okay, I've just named it Reconfigure OSPF Message Digest Authentication on Interface Gigabit Ethernet 0/0. We only have one variable, which is the EEM applet name, which is currently set to new message digest key EEM applet. Also, you can see that the EEM applet name variable shows up throughout our script. Let's have a look at the commands we want to run through the EEM applet. We will be using the iOS config module in Ansible to do this. The applet name will just be the variable. Action 1 is to enable, then configure the terminal, then go onto the interface, Gigabit Ethernet 0/0. Then we're basically just removing the old key and adding the new one. And we finish the EEM applet with an action that adds a syslog priority 3 message, basically saying that the applet was executed. We are registering the output and putting it into a variable. However, this is probably overkill in this specific use case, but in future scripts we may use this function. After this is completed, we're just going to run the EEM applet, which uses the iOS command function in Ansible. And then after that, we will remove the EEM applet after it has been executed. Just a quick side note, the event needs to be set to none for the EEM applet to be triggered manually. Okay, before we run our first playbook, let's just clear logging and just confirm that quickly. Okay, now let's just check that Gigabit Ethernet 0/0 has the correct running configuration. As we can see, it's got the message digest key 1 of Cisco, and let's have a look at the event manager policies, just to make sure that we don't have any there currently. Okay, now back on our Ansible control node, let's run the playbook that we just created for router 3. As you can see, it gives us the play-by-play breakdown. Okay, that's good. The EEM applet has now been created. Now it's been triggered and run on router 3. Okay, we just got the confirmation that everything was okay. That's good. 100% success rate is always a good thing. Okay, let's log back into R3 and let's check that all the changes have been made. Let's also check first that the event manager policy has been deleted. Just quickly referring back to our playbook, as you can see, we wanted to get rid of the EEM applet after its execution, just so we don't have any EEM scripts left on router 3 that could be accidentally triggered. Alright, back on R3, as you can see, the message digest key has changed from message digest key 1 to message digest key 2 with the password of Cisco1 rather than Cisco. It isn't surprising that this worked, as we actually put the script onto the router and then triggered it, rather than sending each command individually. This is why our session wasn't terminated. Just to further confirm this, let's just check our neighbor. Neighbor ID 2.2.2.2 is router 2, and as we can see, it's in the full DR state and it still has those sub-second timers. We wanted a syslog message to be left in the buffer of router 3. This was just to show that the EEM applet had run successfully. Unfortunately, this method could run into issues. It has no error correction, so it's important to know that your configuration will work before you apply it. I'm just going to give a brief example of what would happen if you didn't. In this example, no has been added to both message digest keys. This will leave router 3 in an unreachable state. It's important to also note that in this scenario, the Ansible playbook actually completed. However, the router is still unreachable. We can verify this by looking at our previous router 3 SSH session. Okay, let's console into router 3 and add back the message digest key 1 in order to bring reachability back. Perfect, our neighborship with router 1 just came back online. Okay, let's have a look at our second playbook now. This playbook is still somewhat primitive, however, it will roll back the message digest configuration on Gigabit Ethernet 0/0 if reachability is affected. It does this through the use of IPSLA in a tracked object. When the tracked object goes down, it will trigger a secondary EEM applet, which will undo the specific changes made to the interface. Bear in mind you'll manually need to change this depending on what configurations you'd like to apply. The recovery EEM applet, triggered by the tracked object, needs to put the router back into a reachable state, or this method will not work. Okay, let's look at this new playbook. We now have two variables, the EEM applet name and the EEM revert applet name, which will undo any of the configuration changes we make. This applet will only trigger if the tracked object becomes unreachable. The EEM applet is quite similar to last time, however this time we want to leave the router in an unreachable state. This is so that we can test our revert functionality on the revert EEM applet. Notice here that we don't replace key 1 with key 2, we just remove the key entirely. This will make router 3 unreachable, and ideally, when the tracked object becomes unreachable, we'll trigger the revert EEM applet and revert any changes we made, making R3 reachable again. Let's just have a look at the IPSLA in tracked object configuration. I just labelled it IPSLA 99 and I've got it scheduled to start now and last forever. It will track the reachability and delay any down or change in interface state by 50 seconds. This has been done so that flapping interfaces aren't detected. The IPSLA will actually ping router 1, specifically its interface 0/1. I'm just doing this to confirm inter-area OSPF routing. I'm not going to use the G0/0 interface of router 2. Even in the failure of an OSPF adjacency, router 3 and router 2 will both have connected routes inside their routing table and will still have reachability to each other. I just noticed that our EEM revert applet is actually using a timer countdown. You could do this, however in this situation we want to use the IPSLA tracked object to detect a change in interface state and the reachability of router 3. So let's change this to event track 99, which is our tracked object number, and then the state is down. This should conditionally trigger our revert EEM applet. You know what, while we're at it, why don't we default the interface rather than using the message digest key to demonstrate? Defaulting the interface will definitely cause a reachability issue on router 3. I'm just going to implement these changes now. Just bear in mind with the revert EEM applet, I need to put the original IP address and message digest keys back. Unfortunately, I need to do this manually in the EEM revert applet, as the revert applet will need to negate any of the changes we made. I just pulled the configuration from Gigabit Ethernet 0/0 just to include it in the revert EEM applet. I just really want to make sure that our interface becomes reachable again after we default the interface through our EEM applet. Okay, just editing a few final titles. It looks ready to go. Just for clarification, we will now be defaulting interface Gigabit Ethernet 0/0 on router 3. We will now leave the message digest keys how they are, currently in a reachable state. Defaulting the interface will now be used as a demonstration for an unreachable interface. So the EEM applet will default the interface for Gigabit Ethernet 0/0 just to demonstrate an unreachable configuration. And then the EEM revert applet will apply all of the configuration that is currently applied to the interface as a rollback mechanism after the tracked object determines that the interface has gone down for over 50 seconds. Okay, now let's run our second playbook. Perfect, our IPSLA has been created and applied. Okay, now the EEM applet to revert has been applied. and the primary EEM applet that will be pushing our configuration has now been applied. Okay, we can actually see that our Ansible session has been frozen while trying to execute the EEM applet for the Gigabit Ethernet 0/0 default config. This is consistent with what we expected. Let's log into router 3 now and have a look at what's going on. Okay, yes, the neighborship is down. Let's have a quick look at the IPSLA summary quickly. It's currently in the timeout state, but we need to wait 50 seconds before it actually shows the interface as being down or unreachable. Once again, this will trigger our revert EEM applet and set the interface back to its reachable state. Okay, now just looking at the logging, we can see the default interface EEM applet was executed and the neighborship went down. This occurred roughly at the same time. Okay, it appears it's now been 50 seconds. The IPSLA has now been reported in the down state. Let's see if our revert EEM applet triggers. Okay, perfect. It just showed up on the terminal monitor. Okay, and our adjacency is back online. It seems that the revert EEM applet has worked. Let's look at our adjacencies quickly. And yes, we can see our neighbor, router 2, is online. And now let's look at the running configuration for interface Gigabit Ethernet 0/0. Okay, and once again, it is present, no longer in the default configuration state. Okay, now let's look at the status of our playbook. Okay, it's timed out and failed. Must say, I'm not particularly surprised. As the Ansible playbook didn't fully complete, it would not have removed the individual EEM applets, both the revert and the configuration EEM applet. So let's remove those manually right now. Okay, perfect. While we're at it, let's also remove IPSLA 99. We don't need this anymore. Okay, and let's remove tracked object 99 while we're at it. Okay, now let's run show logging and unpack what actually happened. Okay, as we can see, the default interface EEM applet was executed. Shortly after, the reachability went down. Actually, 50 seconds after. Then the EEM revert applet was executed and our neighborship came back online. Following that, the tracked object went back online again. Okay, now let's get into our final script. This revert script will be triggered using the IPSLA like before, but instead it will actually use the configure replace command alongside the archive feature in Cisco iOS. Use of the archive feature will mean that we don't manually need to undo the changes we make in our initial EEM applet. Instead, we are free to make the changes we desire, and if they don't work or put the router into a reachable state, it will then roll back. We don't manually need to negate the configuration. More specifically, we don't need to undo what we've done. We just need to pull the most recent configuration before we implemented any changes and put the router back into that state. I'm just going to quickly present why the configure replace command, which utilizes the archive feature in Cisco iOS, was chosen over some other alternatives. For example, copy start run, reload in, or configure revert. So firstly, we're not going to use the copy start run because this will attempt to merge the startup configuration with the running configuration. This will definitely run into some unpredictable results or even conflicting configurations. So in contrast, configure replace will allow us to roll back to the exact snapshot we want based on that archive sequence. It also allows us to do it quite quickly with the in-memory config replacement, and no reboot is required either. It can automatically be triggered based on the network state and logged in syslog. In my experience as well, it seems to be less prone to merging errors. So moving on to the config revert timer, one of the reasons we wouldn't want to use this is because it only reverts to the saved startup configuration, which basically means it doesn't support specific archive snapshots, unfortunately. Depending on the situation, we may want not to configure revert or configure confirm. We may want to roll back to a previous archive configuration, not the startup configuration in NVRAM. We're also not going to use the reload in minutes command and reload cancel command. This can be used in certain situations to reload a router back to its startup configuration. However, in this situation, I don't think the downtime would be worth it. The idea of our Ansible playbooks as well is that we minimize downtime. This doesn't adhere to what we want really. So in Cisco iOS, the standout for our script and our use case seems to be configure replace, specifically the configure replace force command. We're going to need to create a directory and set up the archive feature in order to use this command successfully, at least in our rollback use case. Okay, so I'm just going to make the directory now. I'm just going to call it R3 archive configs. And now I'm just going to configure the archive feature and set the path to our newly created directory. Okay, the path is now set. Let's set the maximum history to 10 and let's write memory. Basically what that write memory does is ensure that an archive backup is taken every time you write the running config to the startup config. In our example, we've just used WR. When I run the shell archive, you can see that our latest config has been backed up. And also notice that it's inside the folder that we just created. I'm just going to edit the path, actually the naming scheme of the path, so it adds R3 config before it actually names the file. This will just make it easier to make sure that we're using the R3 config as a backup. I'm also just going to add service timestamps so that they log the date and time. Okay, the files are definitely easier to read than they were before. Now just quickly notice at the end of the file, we have a sequence number. Every time the configuration is backed up, this number will increment by 1. We can see that our next archive backup will have a sequence of 3. If the sequence was 47, for example, we would aim to pick the highest sequence number and incorporate it into our configure replace command. It would look quite a lot like this. So just to quickly summarize, we want to use the configure replace command to select the newest archive backup which will be created before we implement any changes, and we're going to use this for the rollback. Therefore, it's important that we choose the backup with the highest sequence number. Okay, let's go through the final playbook step by step and I will break it down. Okay, first of all, we have 3 variables, one for the EEM applet, the second for the revert EEM applet, which will now use the configure replace command in Cisco iOS. And this will select the latest configuration from our archive backup folder. This backup configuration will be used for the rollback. The final variable we have just stores the archive path that we created earlier. Once again, this is where all of our backups will be stored. Okay, now let's move on to our playbook tasks. The first one being the creation of our backup. Before we make any changes, we do this simply by running the iOS command WR. This latest archive backup will have the highest sequence number. In order to determine the highest sequence number backup, we need to view the directory of our archive. We do that right here and register the output. The output will look like this. Bear in mind it may not be ordered depending on the iOS version as well. I've just highlighted the sequence numbers just to demonstrate that the highest is 46 in this example. Okay, this will show the raw output through a debug and store it in a variable. This just prints out the raw result of the dir command, so you can see exactly what file names and details the router returned. The output is split into a list of lines. Each line is one string within a list. Basically, it filters the output from this to look like this. We will want to further filter and truncate this output so that we can select only the highest sequence backup and incorporate this with our configure replace command on the rollback EEM script. In this example, the highest sequence is now 47. I appreciate that this section of our playbook may look confusing. It basically uses a regular expression to pull out only the actual trailing sequence numbers from those lines and strips out the date and time from the directory output. Basically, most of what we don't need. This debug just prints the cleaned up list of archive config file names, so that we know the filtering step worked. This task pulls just the numeric sequence suffix from the file names and converts them to integers. It picks the highest one, which represents the most recent backup, as ordered by the sequence number. It will store this in the latest backup variable. It will literally just leave the highest sequence number, which in this scenario is 47. This debug will just print the latest archive number so that we can verify that Ansible has found the correct file. This task will then use the latest backup number to find the exact file name from the list of archive files and store it in the variable rollback config. This debug will print out the final file name that will be used in the configure replace command later on. The rollback config variable will combine both the file name and the latest sequence number. This will allow us to use the rollback config variable directly in the configure replace command syntax. In our example, the rollback config variable would look like this, and the archive path variable, which is static, would look like this. We combine the archive path variable with the rollback config variable inside the EEM revert applet using the configure replace command like this. Notice how the / separates both of the variables and create valid syntax. Once again, referring back to our example, the configure replace command would look like this. Okay, that was a very long explanation to basically say that the latest backup will be used for rollback. Just a heads up, we will still be defaulting router 3's gigabit Ethernet 0/0 interface and then rolling back after the tracked object is triggered. Let's stop discussing the playbook and instead let's run it. Okay, let's just type it in now. Here we go and enter. Okay, as we can see, the initial archive backup has been created. Okay, now the archive directory output is being shown through the debug feature. We just wanted to have a look at the dir output. Okay, perfect. The truncated file names are now out as well. And as we can see, it has successfully chosen number 58, which is our latest archive sequence number. The IPSLA is being created currently, and the EEM applet to revert changes has also been created. It looks like we almost have all of our prerequisites ready. Also, the rollback configuration variable, number 58, has been created as well. We're currently executing the EEM applet to default gigabit Ethernet 0/0. Now bear in mind this will fail. And as expected, it's failed. Let's have a quick look at router 3 now to determine whether or not it rolled back successfully. It rolled back successfully. As we can see, router 3 has its gigabit Ethernet 0/0 interface configuration reapplied. Let's have a quick look at the archive configuration differences. And there might be a few differences specifically relating to the terminal width. However, no notable changes really. This is definitely the backup configuration we aim to push. Let's just run the playbook again, but stay on the router's console session this time. We're going to use the console session just to ensure that we don't lose our connection, as it will flap. Okay, we currently have no event manager policies registered. Okay, just quickly judging by our terminal monitor, the disk has just been written to. This means that our backup configuration is sequence 10. Let's have a look at interface gigabit Ethernet 0/0. As we can see, all of our configuration is there, at least currently. Let's now have a look at the event manager policy. As we can see, the revert EEM applet is now present. Let's run this command again. As we can see, now both the default interface EEM applet and the revert EEM applet are now present. Our IPSLA has been created, and as you can see, it's beginning to time out. It says 12 seconds ago now. Let's now have a look at the configuration differences between sequence 10 and our current running configuration. As you can see, our backup configuration did not have the revert EEM applet or the default EEM applet. However, it did have configuration applied to the interface gigabit Ethernet 0/0. Let's check that this is correct by showing the run on interface gigabit Ethernet 0/0. And yes, it does appear that this interface has been defaulted. It also appears that it's been longer than 50 seconds, as our tracked object has now entered the down state. We can see from the terminal monitor that Rollback has acquired configuration lock. That's a good sign. The revert default EEM applet has now been run, and as we can see, our neighbor's adjacency has come back online. That means we have reachability. Let's just run that configuration differences command one more time, and there are no changes. This means that our backup configuration, sequence 10, has been applied. Also, something to note, all of the Event Manager policies have been removed. We can confirm that Gigabit Ethernet 0/0 has its configuration reapplied. Let's have a quick look at the log. Yep, everything looks to be in order. I would classify this as a successful rollback. Don't hesitate to let me know if you have any questions. Once again, my GitHub will be linked in the description. This was quite a long video, but I do hope you found it at least somewhat informative. Thank you.